XTDB is an immutable SQL database built to simplify application development and data compliance. In my element trading shop, I have to handle many rare elements. Each product comes with its own set of unique physical properties like melting points and crystal structures. Using XTDB, I can manage these properties as deeply nested records while leveraging the flexibility of its schemaless design. Let me show you how this works. So with our products table filled with data from our previous video and records, we begin by having a look into its schema. Since XTDB automatically infers schema dynamically from its inserted data, we're able to just use a query to see the structure. Here we can actually see the columns that XTDB has inferred, including the properties column, which is automatically able to store nested data. This makes it easy and intuitive to track the detailed characteristics of each element. Now let's add gold as the new element within our catalog. Gold has a unique crystal structure and specific thermal properties, so we'll need to store this nested like our other entries. The record syntax allows us to insert the nested data like this in a way that's easy to work with. Let's just check that gold has been successfully added, and as you can see, all of the elements are within our table. With gold added to our table, we can now leverage XTDB's intuitive syntax for querying nested data, kind of reminiscent of JSON or array access methods. By treating thermal properties field like one would a structured array, we can directly access specific indexes within it, such as its first one. So to retrieve gold's melting point, we can just do this. This flexibility makes it effortless to work with these kind of data structures. But what happens if, due to a shortage, gold is temporarily unavailable? In XTDB, deleting a record is actually just a soft delete, meaning the data isn't lost, it's simply hidden from the view. So let's run that with this transaction and go back to our old query. Now gold's record is no longer visible, which is what we wanted. However, because XTDB bitemporally preserves the history of all changes using granular snapshots with system time, we are able to compose a specific query to restore gold back into our table. With this kind of combo transaction query, where we identify gold by its ID, we can retrieve gold's most recent version and reinsert it back into the table. And if we check right now, we can see that gold is back, just like it was before the deletion. We can also use gold's ID to query for it for all system time, so that we can check that there are two systems that it has been a part of. Finally, if we decide to retire gold permanently from our catalog, due to it now being out of stock permanently, we can implement XTDB's erase operation to perform a hard delete. This ensures that the product data is fully removed, even from XTDB's system time and transaction log. So, XTDB's ability to manage nested data, handle soft delete, and recover past states makes it an incredibly powerful tool for my shop. Whether I need to query specific details, correct mistakes, or maintain an auditable history of changes, XTDB ensures I always have complete control. We'll be back with more XTDB videos real soon.